Hello everyone, I hope you're doing well from wherever you're watching from, and thank you so much for watching this session. This is part 2 of this series, and in this session we will be focusing on how to configure OSPF on Nokia routing devices. So when you are doing BGP implementations, before you start establishing BGP peering session between different nodes, you need to ensure that you have reachability between the different nodes. If you are using eBGP, definitely you are using the point-to-point IP addresses, so you don't need any IGP or any routing protocol. But when you are configuring iBGP peering session, many times we use the system IP addresses or the loopback interfaces to establish these BGP peering sessions. If you know the reasons why we prefer using the loopback interfaces or the system IP interfaces to establish the BGP peering session, kindly let us know in the comment section. So you need to ensure that we have reachability. You need to ensure that we have connectivity and the nodes are able to communicate with each other before we can do the BGP configurations. So this is what we are starting in this session. We need to configure OSPF in AS65000 just to ensure that we have reachability between R1, R2, and R3. And then we'll go ahead and do the BGP configuration in the upcoming sessions. So we know that OSPF is a very common routing protocol. You will definitely have OSPF configured in your network, especially if it's a service provider network. This is an IGP, it's a link state protocol. So if you haven't explored the features of OSPF, you can read more about it. So you need to understand how to configure OSPF. That's why we are having this session to help you understand how to configure and troubleshoot OSPF on Nokia routing devices. In the last session, we already demonstrated to you how to do the basic configuration, the interface configurations, the host name configuration on Nokia routing devices. So if you haven't watched that session, kindly check it out, and then you can come back and watch this session and also follow up with doing the lab in your setup. So we need to configure OSPF in AS65000 so that we can establish iBGP peering session between R1, R2, and R3 using the loopback IP addresses. So this is the goal of this session, just to configure OSPF, verify that everything is okay, verify that we have adjacencies coming up, verify that we can be able to reach the loopback IP addresses from different routers. So from the setup in the previous session, we already did the interface configurations. For example, on R3, I can show router interface, and you'll see show router interface. You see that we have 3 interfaces. Actually, we have 4 interfaces: physical interface towards the peering device, the remote devices, and then we have the loopback or the system interface. So we have a connection to R1, we have a connection to R2, R4, and R6. We should be able to ping. So if I ping 10.10.10.0 on R1, should be able to ping. If I ping 10.10.10.2, I should also be able to ping the point-to-point configuration between R1 to R3 and R2 to R3. So this confirms that we have connectivity in AS65000. Now we also need to ensure that from R3 we are able to reach the loopback IPs of R1 and R2. So if I try to ping 1.1.1.1, you see that we are not able to, we don't have this route. .2 should be the same. We are not able to reach these IP addresses. I can try show router, route table. And you see that we are only learning the directly connected IP addresses. So for us to be able to learn these routes, we need to have a routing protocol, and that's why we are configuring OSPF so that we can have these routes advertised between R1, R2, and R3. So let's look at the OSPF configurations. We first need to create an OSPF process. Same if you are doing the implementation on Nokia, if you are doing the implementation on Juniper or Huawei, ZTE, you need to create an OSPF process. If you don't specify it, then by default, it will be process 0. But for this case, we are creating OSPF process 10. And then you need to configure the router ID. The router ID plays a very important role in OSPF. For example, it can be used as the identity when you are checking the LSDB, when you are checking the DR, BDR. All these can be referenced using the router ID of this router. And then you need to activate OSPF in the respective areas. In this setup, we are only creating area 0. So you use the command area 0, and then this is how you activate OSPF on the interfaces. You need to list these interfaces. You can also define the interface type that we are configuring. We can either have point-to-point or broadcast. In this setup, we are using point-to-point. And then you also need to run the no shutdown command. We do the same for the point-to-point connection interfaces. This is to R3. We configure the interface type to point-to-point, and there are so many other parameters that you can configure when you are setting up OSPF on Nokia routing devices. But remember, this is just a basic implementation so that we have connectivity between these different nodes. After this, we go to R2. R2, we do the same. We configure the OSPF process. We configure the router ID. And again, when you are doing the implementation, you can configure the router ID globally. You don't need to specify router ID under the OSPF process. But in this setup, we just go ahead and configure it under the OSPF process. But you can configure it as a global parameter. So on R2, the route ID should be .2, and then we have these two interfaces, the system interface and the interface to R3. Finally, on R3, we have multiple interfaces. We configure the router ID, area 0 again. You need to specify the area, and then you activate OSPF on the interfaces. So we have interface to R1 and R2. And these interfaces should have been created before. That's why we started with the interface configurations. After this, we can go ahead and do the verification to ensure that our adjacent these are up. We are able to learn the routes. We are also able to communicate between different nodes. So let's start by configuring R1. So I'll copy this. Again, when you are doing the configurations on Nokia, always remember that you need to do proper formatting of your commands. So on R1, I need to run these commands. So I've done proper formatting, and you can see that we don't have any errors. I'll go ahead and copy the commands for R2. So on R2, we need to configure these commands. I'll go to R2. Always ensure that you are on the correct device, especially when you are doing the configurations in the live network. Finally, on R3, we need to run these commands. So I go to R3, run the commands. So we've completed the command. We've applied all the commands that we need to apply on R1, R2, and R3. Now let's look at the verification command. We can start by checking the interfaces that have activated OSPF. So you run the command show router OSPF interface. When I do that, let me go back to the CLI. So on R1, I can show router OSPF 10 interface. You see that we have these two interfaces activated with OSPF. You should be able to run the detail command, and you are able to see multiple parameters. You are able to see the hello intervals, the transmission interval, the date intervals. You are able to see the configured metrics. You can see many other parameters. The backup designated router, the operation state is point-to-point. The interface type has been configured to point-to-point. The polling interval is set to 120 seconds, and many other parameters. The statistics, how many hellos, how many DBDs, LSRs, LSUs, all these parameters. Do we have any discards? Do we have any bad authentication type? All these different types of information, you can see it when you run the command display router, I mean show router OSPF 10 interface detail. Next, we need to check the neighbors. So we run the command show router. Let me do it on R3 because we have multiple adjacent this show router OSPF 10. So you need to give the process. If you don't give the process, it will use process 0. So it's always good that you give the process. So if I do neighbor, you see that OSPF instance 0 is not configured. So we need to specify the process, which is process 10. And then you run the neighbor. You can also add the detailed command so that you can see the uptime. Have you enabled graceful restart? The neighbor state is full. If you understand the OSPF state machine, priority, the backup designated router, the last event time, and many other parameters that you can observe when you run the detailed command. After this, we can also check the routes. So we can run show router OSPF routes, and we should be able to see that these are the OSPF routes that we've learned on this router. You can see that we have 1.1.1, 1.1.1.2. These are OSPF routes that we've learned on this routing device. We can also see the LSDB. You use the database command to see the LSDB. You know the different types of LSA that we have. The router LSA, which are the type 1 LSA. If you have multi-area OSPF, then you will be having multiple LSAs from different areas, type 1, type 2, type 3. So these are some of the details that you need to pay attention to when you are configuring or troubleshooting OSPF or Nokia routing devices. So you can also show router route table. If I run show router route table to see whether we have OSPF routes installed, you will see that yes, we have 1.1.1, which is an OSPF route. We also have 1.1.1.2, the loopback address of R2 that is being learned through OSPF. You can also specify the protocol. So we can run show router route table protocol OSPF. And you see that we only have these two routes that we've learned through OSPF. You see the metric, you see the edge, protocol is OSPF, you see the prefix and the mask, and then the next hop for reaching these prefixes. You can also run the command show router OSPF statistics. So let me specify the process OSPF 10 statistics. And you can see that these are the different statistics for different packets, the hello packets, the RX, the DBDs, the LSRs, the authentication, bad authentication. A lot of information that you can check, especially when you are doing troubleshooting of an OSPF network. Finally, we can try to ping. So from R1, we were not able to reach, from R3, we were not able to reach R1 and R2. But now that we have the routing information, we should be able to reach these IPs. So you can see that now we have connectivity from R1 to R3. We can also ping from R3 to R2. So this confirms that our OSPF is well configured. We now have connectivity between R1, R2, and R3, and we can now go ahead and do the BGP, iBGP configuration using these IP addresses, the system IP addresses. So again, tell us in the comment section why we prefer using the system or the loopback 0 IP address for iBGP peering sessions. Thank you so much for watching this session. I hope you've enjoyed it. Just a kind reminder that if you've enjoyed this session, but you are yet to subscribe to our channel, kindly support this channel by subscribing to it. Also remember to like, comment, and share this video with your connection. Thank you so much and see you in the next session.